Alright, so this video is to refresh your memory about the chi-square test. And remember, the chi-square test is used to determine independence. So there were four main steps when it came to doing chi-squared. They were to write the h sub 0 and the h sub a, aka the null hypothesis and the alternative hypothesis. You had to calculate the chi-squared test statistic. You had to calculate the critical value. And then you had to compare the chi-squared test statistic to the critical value, or the p-value to the significance level, dependent on what you basically depending on what you were given in the particular problem. So we break them down step by step. The first step, again, was to write your null hypothesis and your alternative hypothesis, and those are written basically in this format: blah 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 is independent of blah blah blah. And so it pretty much would be based on whatever you were given the problem, but that is the setup. Okay, I remember from last year some of you guys try to do dependent of. No, the proper formatting of these sentences are blah 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 is independent of blah blah blah. Okay, and it was always your y, like what was considered your y will go first, like your dependent variable will go first, and then your x will go last. The alternative hypothesis is the exact same, except this time it's with a not. So blah 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 is not independent of blah blah blah. That was the setup for step one. Okay. Now step two. This is when you had to go into your calculator and type in your data. Okay. For your IAs, you had to do chi-square by hand, but for your actual exams, you actually can use your calculator. And so remember the process of doing this to type in the table was you had to go to your matrix, and you got your matrix by pressing your second button and your x to the -1 button. I'm gonna pull up a circle function. So you press the second button, and then you had to press the x to the -1 button, and then you would get this screen right here. Your names, math, and edit. And what you had to do is you had to go over to edit and basically type in your contingency tables into matrix A. So when you go into edit and you click enter on matrix A, you would type in the dimensions of the matrix, and you would basically fill in. So if it was a 2 by 2, you did 2 and 2, and you typed in the data. 4 by 4, you did that. Okay. And then after you typed in your data, you had to go back to stat, and then you had to go over to test, and you had to scroll all the way down to option C, which was the chi-square test. Okay. And then what you basically had to do was, put in matrix A and then press enter. And refresh your memory as we go over the two examples that follow after we go over all the steps. But that was pretty much the basis. Second, x to the -1 took you to where you typed in your data, or you typed in your tables, and then stat, go over to test, and that's where you actually got the chi-square test. Now, one thing with step two, there was the expectancy table that you also had to do. I know some of you guys, last year you were like, oh, well, once you perform the chi-squared, your expectancy table is given to you in matrix B, which is true. It does do that. However, if you have to show a particular expected value, you had to take your row total times your column total and then divided by your overall total. That's how you actually got each one of. That's how the calculator gives each one of those entries in the expected table. Okay, and that is from your original data that you're given. Step 3, your critical value is always given to you on your test. Okay, and so I know step 3 was to find the critical value. Well, on your test, the critical value is given to you. If it's not, then you'll at least know the significance level. Either way, you'll be able to do step 4. So really, step 3 is kind of just like, okay, kind of see, well, what do I have? Do I have the critical value, or do I have the significance level? Do I have both, one or the other? So that way you can do step 4, which is actually to either accept or reject the null hypothesis. So if you are given a critical value and you do perform the chi-square test statistic, if the chi-square test statistic is less than the critical value, then you accept the null hypothesis. Okay, that means that whatever the null hypothesis was is exactly true. However, if the chi-square test statistic is more than the critical value, then you reject the null hypothesis, which means that that whatever you originally said is actually dependent of the other. But if you're not given the critical value, and you have to, and you still have to decide if you're going to accept or reject the null hypothesis, then you can always compare the p-value to the significance level. If the p-value is less than the significance level, then you reject your null hypothesis. But the p-value is more than the significance level, then you accept the null hypothesis. And this right here is going to be very crucial. Okay, you don't want to mix this up, so definitely write this down. It's not in your reference booklet. None of these steps are in the reference booklet when it comes down to chi-squared. So you're definitely going to have to remember each of these steps. Okay? So here's an example that we're going to take a look at first. It says a group of 100 students gave the following responses to the question of how they get to school. So you have this data here. You got males and females, walk, public transportation, car, bicycle, and then you have the respective totals. Now it says a chi-square test for independence is conducted at a 5% significance level, and the null hypothesis is defined as the method of getting to school is independent of gender. Do you see that makeup of that sentence for the null hypothesis? Blah, blah, blah is independent of blah, blah, blah. That right there, that is crucial. If you had to write that yourself, then you would do the same thing, okay? So, like I was trying to explain before, this part, the part that goes before, is that this part that follows, the part that's actually before that is independent of, that's kind of like your y, or your dependent variable. In this case, how the person gets to school is very much going to depend on who, what their gender is, okay? So it's almost like this is the x, like if we were to graph this data, this would be your x and this would be your y when it comes down to the makeup, if you had to write it yourself. Luckily enough, you didn't have to write it yourself. Now it says find the expected frequency for females who use public transportation to get to school. Okay. Now this is what I was talking about, that little extra side note right here. If it actually asks you to show or find a particular expected value, you take the row total times the column total and you divide it by the overall total. So in other words, to find the expected frequency for females who use public transportation to get to school, well, you take the female total, which is 48, you multiply it by the public transportation total, which is 30, and then you're going to divide it by the overall total, which is 100. That's how you find an expected frequency of a particular value. You just go to that particular total, that row total, that column total, and you divide it by the overall total. Okay, so we go to our calculator and we type this in. And the expected value is 14.4. So that will be our answer there. And when we actually look at our expected tables after we perform the chi-square test statistic, then we'll know that the value of female public transportation, this spot right here in our table, will be 14.4. Now you actually have to find the chi-square test statistic. So this is when you go back to your calculator. Okay, you got to go to second x to the -1, and everybody should be doing this with me, okay? Just to make sure. It's all about muscle memory practice. You go over to edit, and then you want to put your observed data, so basically your data that you're given, and you want to type that into matrix A. So what kind of a matrix is this? This is and remember, the order goes rows by columns. So we have 2 rows that represent the gender, and we have 4 columns that represent the method of getting to school. So this is a 2 enter by 4 enter matrix, and it will pop up, and it should be the same size as the matrix that's in your data. Okay, so now we're going to type in our data. It's going to be 18, 13, 14, and 3. So 18, enter, 14, enter, oops, it's 13, sorry. Mess up, just go back. 13, enter, 14, enter, and 3. Okay, you guys fill in the next row. So once you have your data in there, what you have to do is you want to get out of this. So you're going to do second mode. Okay, go back to your home screen. So second mode takes you back to your home screen. Then you're going to go to Stat. You're going to go over to Test, and then you're going to scroll up to get to option C, which is the chi-squared test statistic. You're going to click Enter. Now, if your screen looks like mine, then you're good. Observed is in A, expected is in B, and all you got to do is hit Calculate. However, for those whose calculators do not look like that, actually, I was wrong. Everyone's calculator is going to look like that. It's going to have observed, expected. You probably are going to have a color like mine, but it really doesn't matter, okay? It doesn't matter what color it is. Just go to Calculate, and there's our answer. Our chi-squared is going to be 12.9554, which basically, when we round to 3 significant figures, is going to be 13.0. Okay, now there's really not too much work that you can show for this. Something like this is going to be straight calculator problems, okay? So now it says the chi-squared critical value is 7.815 at a 5% significance level. This is what I was talking about in step 4. They give you the critical value, you can compare it to your chi-squared test statistic. Or you can take your significance level and compare it to the p-value that's here on your calculator as well. So, state whether the null hypothesis is accepted or rejected. Well, if I compare our our chi-squared test statistic, which is 13.0, to our critical value of 7.815, we can see that the 13.0 is greater than our critical value. And when that happens, you are going to reject your null hypothesis. Okay, so when the critical value is more, when the chi-squared test statistic is more than the critical value, you're going to reject your null hypothesis. So when it asks us to give a reason, the math right here is our reason, and we are going to say we reject our null hypothesis. Or you can say we are not going to accept our null hypothesis. And that's your chi-squared test statistic. Let's take a look at this one. Okay, I want you guys to pause the video. I want you guys to work this one out and then check your answers. When you're ready to check your answers, press play. So pause the video. All right, so you had to write down your null hypothesis. And as we can see, the Y, quote unquote, the Y is going to be the type of Latin dance. So my null hypothesis is going to be the type of Latin dance is independent of, remember that format, of your age. Because basically the producer was basically asked a group of 120 people their age and their type of dance they preferred. So the type of Latin dance is independent of age. Now, if you said dance is independent of age, that would also work. But basically, that's you dance first and then age second. Then you have to write down the observed number of viewers who performed a rumba and were older than 20 years old. So that's another, so you basically had to write down, so it's right in front of you. Observed number of viewers who performed the rumba and were older than 20 years old. So that was talking about this data entry right there. You just had to go to your data and look to see, okay, how many people was that? Because remember, this is your observed data. The expected data is when you actually go through and you do the whole row total times column total. Now it says, use your graphic display calculator to find the p-value of the test. Now, you do it the same way, okay? You go to second, x to the negative 1. You go over to edit, and you type in your data into matrix A. You exit out of there. You go to stat, over to test, and you're still going to C, chi-squared test statistic, okay? I think my calculator is about to shut down because it's not moving now. All right. But that's okay because I do have a backup. I have my actual personal one. But basically, you would still go back to chi-squared test statistic to go ahead and figure this all out. because remember, not only does it give you the chi-squared, but it also gives you the p-value as well. So I'm just going to update this, type this into my calculator. Okay, observed is still A, expected is still B. I'm going to go to calculate, and your p-value should be the same as mine. Rounded to 3 significant figures is going to be 0.0876. Now that is 3 significant figures. Before, like, this was the decimal that you should have gotten. But when you round that to 3 significant figures, you always start with your first non-zero number. So that's going to be the 8. That's your first significant figure, followed by the 7, which is your second. And then the 5 is going to get rounded up to 6. And that's your p-value. Now it says the producer claims that the type of Latin dance a viewer preferred is independent of their age. We have to decide whether the claim is justified. Okay? Well, since we have the p-value here, we will want to compare with our significance level. Okay, 5% as a decimal is written as 0.05. And so we have to compare that to 0.0876. Now, when we look at this, we have to decide, is 0.0876 less than or greater than 0.05? And in actuality, this value is going to be greater than 0.05. If you think of a number line, 0.05 is here, and then 0.0876 is here. So this is actually going to be greater than this value. And so if the p-value is greater than the significance level, so if it's more than the significance level, you accept it. Okay, so if you accept your null hypothesis, that basically means that Latin dance is independent of age. The type of dance is independent of age. And the producer said that Latin dance is independent of age. So is the claim justified? You would say yes, it is justified. And then give a reason for your decision. You would say because the p-value is more than the significance level. And you can have the numbers as well to support it. Okay. So I hope you guys, if you have any questions, of course, please let me know. At this point in time, you're going to be working on. At this point in time, you're going to be working on your chi-squared test review packet.